Hello, family. Welcome to another session of Maths Fanatics. In this question, we're going to be looking at calculus. Okay. So, the first question, they want us to determine the derivative from first principle of f of x. Okay, first principles. So 9.1. The formula for first principles is this: derivative of f of x is the same as limit as h approaches infinity of what? F of x, sorry, f of x plus h minus f of x all over h, right? But before I start with first principle, I always just do it using the rule so that I know what my answer is going to be, right? Remember here I have 1. So if I do the rule, it's going to be 1 times 2, which is 2x. And then 2 minus 1. Remember, always minus 1 on the exponent, right? So it just remains that. Then here there's an invisible 1 as well. 1 times negative half, it's negative half. And then here you're going to have 1 minus 1, which is 0. So this part will disappear. So my answer must be this at the end. Okay. Perfect. So now I'm going to start doing first principle. Né? Okay, I know that my f of x is what? It's x squared minus half x, right? Okay, I know that there I'm going to substitute this, right? Now let's find f of x plus h. F of x plus h means where there was x, we replace him by x plus h. Do you see? It's still f of x, but where there was x, we're going to replace with x plus h. So what do you do? Where you just rewrite f of x the exact same way it is, but where you see x, you open a bracket, minus half. I'm seeing another x there, then there's nothing, so I'm not going to write anything there. Awesome. But if there was 5, I would say plus 5 there. Does make sense. Now, inside this bracket, you're going to put x plus h now. X plus h. Then let's simplify this. So here's going to be x plus h squared minus half x, or let's just say x over 2 minus h over 2, right? Perfect. Which becomes x plus h. Then another bracket, x plus h minus x over 2 minus h over 2. And then we're going to start foiling now here. X squared, xh, xh, h squared. We said what? X squared plus is going to be 2xh. Now I'm already simplifying. Plus h squared, right? Minus x over 2 minus h over 2. Perfect. So because remember, these ones are over 1, over 1, over 1. Now I just want to do the LCD same time. So here, should we do the LCD? Nah, let's not do it. Let's not do it. So now we can substitute. Né? Let's go back to our red color. But you show all the working out. Now I'm going to substitute the derivative of f of x as the limit approaches, as h approaches 0. Remember, f of x plus h is this. Né? So I'm going to replace it with this. So this part gets replaced by that part, which is x squared plus 2xh plus h squared minus x over 2 minus h over 2. And then we're going to minus f of x now. Remember, f of x gets replaced by f of x, which is x squared minus x over 2, basically. Okay. And then, guys, my advice is this. F of x is always going to disappear. Né? F of x is always going to disappear. For example, this x squared will cancel this negative x squared. Né? This one will cancel that one. Né? But remember, we have all over h, right? Then now we can have limit as h approaches infinity. We're left with what? 2xh plus h squared minus h over 2, right? And then all over h. Actually, I don't like writing it this way. If I have three, so I already have two things and another one, I would rather write it in this form. Ne? Remember, this can be written as multiplied by 1 over h. Ne? Okay, perfect. So now I'm going to take a common factor out. I'm seeing that all the terms have an h. So I have limit as h approaches 0. You keep on writing the limit as you go down, right? I'm taking h out here as my common factor. So here I'm left with 2x. Here I'm left with h. Here I'm left with negative 1 over 2. Then multiply by 1 over h. Ne? If you check, this h is at the top will cancel with that one at the bottom, right? So we have limit as h approaches 0, 2x plus h minus half, right? Then we can see that if I substitute the 0 there, I will be just left with 2x minus half. So I usually advise you to not show the substitution of 0, but I don't think they'll penalize you. But remember, h is approaching 0. It never reaches. Ne? So you usually just work it out in your brain. So I know that this part is going to disappear because it will become 0. So I'll be left with that part and that part. And the step after a substitution, you no longer write the limits. And then this is your answer, which is the same as that one. Then you know you're fine. If you get something different, you know you made a mistake somewhere. Okay. Let's check 9.2. Here they want us to find the derivative with respect to x. Ne? So, okay. So we have d with respect to x of 3x4 plus 5 square root of x plus a squared. Okay, this one looks a little bit challenging, but it is not. I'll show you now. So they said with respect to x. Ne? This one is the variable. This one is a variable. Any other letter is not a variable. This is a constant. Ne? Because they only say with respect to x. So the a is going to be a constant or just a number. So you're going to treat it with like 3, 4, 5, 6, 7, like -5 is just a number without a variable. Okay. So I have to set up first. Let's see. So I have 3x4. Remember here there's a hidden 1 and then a 5. To change from a root to exponent, you write your x, right? And then this becomes the denominator. I mean numerator. This becomes the denominator. So you have x1 over 5. The inside exponent is the numerator. The outside is the denominator. Okay. Plus a to the power 2. Now we can differentiate. Now when you differentiate this part in the bracket, disappear. So it's going to be 3 times 4, which is 12x. And then 4 minus 1 is 3. Remember, you always multiply them and then you always minus 1 on the exponent. Here there's an invisible 1. So 1 times 1 over 5, you have 1 over 5 x. And then here you're going to have negative 4 over 5 when you minus 1. Yes, perfect. And then this part, remember, I said you treat it like a number, né? So it becomes 0. So it disappears, basically. Because we are differentiating with respect to x, not with respect to a. What I'm saying is, let me show you another example here. If they said d over dA, right? And then you have, let's say 3x4 plus a squared, né? So your answer here was going to be this. This part, you treat it as a constant. So it becomes 0 when you differentiate it. That part, because you are differentiating with respect to a, this part, this times that, 1 times 2 is 2a. You get it? So you're gonna get 2a. I'm sure it makes sense now, right? You always differentiate with respect to the letter written there. Okay. Let's do 9.2.2. 9.2.2. So on 9.2.2, we have x, y equals to x squared plus x minus 1. I just rearrange them, x squared there, x there. Ne? Sharp. Before I differentiate this side, there must be y only, because it's dy over dx. Do you see? So I'm going to divide everything by x, obviously. Divided by x, divided by x, divided by x. So I have y equals to x squared over x gives me x. This part will give me 1. This part is already simplified, but I'm going to move x to the top, ne? Which becomes, remember, if the exponent is positive, when you go up, it becomes negative. So it's negative 1x. Ne? Now I can start doing my dy over dx. This one, there's 1, there's 1. So I'm just going to have 1 because 1 times 1 is 1. And then 1 minus 1 will give me 0 here. So x to the power 0 is 1. So I'm just left with 1 there. The derivative of a constant. So a constant is a number without a variable. Ne? Is a term without a variable. It's always 0. So this part becomes 0. Then here, negative 1 times negative 1 is positive 1. X. And then here, negative 1 minus 1, it's minus 2. Then we're done. Ladies and gents, please share this with family and friends. And don't forget to hit the subscription button if you haven't done so yet. Thank you.